Today we're going to be looking at dividing polynomials. First of all, why do we need to do this? We are going to be factorizing complex polynomials to find all the roots. We want to do it with some understanding of what we're doing. Okay, I want you to do it with some understanding. And obviously, we all know how to factorize a quadratic, but sometimes we want to factorize a polynomial of a higher order, and this is a really good way to do it. So first of all, I want to start by just reminding you of long division. So say I had 3,756 and I wanted to divide it by 23. Okay, we would have said 3 goes into 23. I can't do that. 37 into 23 goes once. 1 times 23 is 23. Draw the line and I'm going to subtract. 7 take away 3 gives me 4, and 3 take away 2 gives me 1, and then I bring down my 5. 145 into 23 goes 6 times. You can use a calculator when you need to. 6 times 23 is 138, and when I find the difference between those, I can borrow and I will get 7 over there, and that's all fine. Bring down my 6. 76 into 23 goes 3 times. 3 times 26 is 69. And when I subtract those, I get 7. So basically 7 doesn't go into 23. You could have carried on with your dots and everything. We want a remainder at the moment. So I would say 3,756 divides by 23 163 times with a remainder of 7. Or you could say 163 and 7 23rds. Okay, so that's just a reminder of your long division. Let's look how it would look if we were using a polynomial. So say I was going to divide some polynomial f of x, which is 3x squared plus 5x minus 8 by x minus 2. Well, I'll set up my division in the same way as I did before. Need a lot more space. And this is 3x squared plus 5x minus 8. Now, you want to keep all your lines really neat and keep everything in order, and that would be helpful. Okay, so first of all, 3x squared. I'm going to mostly be dividing by the first value, the highest order of my divisor. So 3x squared divided by x gives me 3x. And 3x times x gives me 3x squared, and 3x times negative 2 gives me negative 6x. Now I'm going to subtract. Remember, if I'm subtracting, that negative goes to both terms, so that's going to become a plus. So that's going to cancel out. 5 plus 6x gives me 11x. And I bring down my negative 8. Okay, so now I have 11x that I'm mainly looking at, and I'm dividing by the highest one again. 11x divided by x gives me 11. 11 times x gives me 11x, and 11 times negative 2 gives me negative 22. Again, I'm going to subtract. That negative goes to both terms, so that's going to become a positive. It's always good to change it here. Make sure that you're going to be doing the right thing. 11x minus 11x is 0. If this one doesn't cancel, it means you made a mistake somewhere along the line. Minus 8 plus 22 is going to give me 14. So I don't have an x here anymore. I can't divide that anymore. I'm finished. And so I can say, I know from this that 3x squared plus 5x minus 8 is equal to x minus 2 times 3x plus 11 plus a remainder of 14. Or I can say that f of x, in this case, divided by x minus 2 gives me 3x plus 11 plus 14 over x minus 2, because I always put my remainder over my divisor. So those are equal statements. Okay, so have a little think about that. If you need to rewind and look at it again, that's awesome. What I'm going to go straight onto now is the next bit, is we're going to think about our remainder theorem. I'm just going to leave those numbers there. I just first of all want you to notice what happens if I put if I put 2 into f of x. So remember, f of x was 3x squared plus 5x minus 8. So now f of x is equal to 3x squared plus 5x minus 8. So now f of 2 would be 3 times 2 squared plus 5 times 2 minus 8. 2 squared is 4. So 3 times 4 plus that's 10 minus 8, which is 12. 10 minus 8 is 2. When I substitute 2 into here, I get 14, which was my remainder. So I can actually find out what my remainder is going to be by substituting what I'm dividing by, or what I'm hoping is maybe a factor, in. And if I get an answer, or whatever that answer is, will be my remainder. If a polynomial, f of x, is divided by some x minus r, and a remainder r is obtained, then f of r, opposite sign of that, is equal to capital R, my remainder r. That's quite a bit to take in for now. Have a little think about that. You might want to watch the video again, try some of your own values, see how you go. Thanks for watching.